the fundamental theorem of calculus. Usually we call this FTC, fundamental theorem of calculus, FTC. Let's say we have a function f of x and this curve is the graph of f of x. We are looking for the area under the curve where x goes from A to B. So to find the area, we studied three methods in the past: the left sum, the right sum, the midpoint sum. But those three methods give you an estimation, because whenever you are using the rectangle to estimate the area, usually they are underestimation or overestimation. But this method gives you the exact area under the curve. So here is how the FTC works. First, we will have to set up a definite integral. So we have a definite integral where x goes from A to B. The integrand is the function, and then the differential is dx. So dx tells me that x is the independent variable, and that is equals to the area under the curve of the function from x equals to A to x equals to B. And here is how the FTC works. First, we take the antiderivative of the function. Later on, we will just call this, we are trying to integrate f of x. So we integrate f of x to get the capital F, and then we plug in B, and then we plug in A, and then we use f of B to subtract f of A to get the area. Alright, so for the FTC, I have 5 examples for you. So these are pretty basic examples to understand how the FTC works. So let's do this one by one, starting with the one on the left. So the first one we have is we have integral. X goes from -1 to 3. The integrand is 3x squared plus 5x dx. So the first step is antiderivative, or you can call this integration. So we integrate the functions. So what is that equal to? So integrate, that means you don't bring the 2 down, right? You are not taking derivative. You are trying to undo the derivative. So this will be 2 plus 1. Derivative, you bring it down, you subtract 1, right? For antiderivative, you add 1, and then you do that in the denominator. And then plus, this becomes x squared, 1 plus 1, and then you have 5 divided by 2, such that x goes from -1 to 3. And then I have to ask you to check this. So how do I know this antiderivative is right? The answer is very easy. Simply take the derivative of this, and then you will be able to get back to the integrand. So take the 3 down, take the 2 down. Do you see that you can easily get back to the integrand, right? So let's clean this up. That is equals to x to the third, and then plus 5x, 5 over 2 x squared. 5 over 2 x squared, such that x goes from -1 to 3. And then the next step is we can do what? We can just apply the FTC, right? Plug in -3 and then subtract, plug in -1. Notice that this is a subtraction. F of B minus F of A is a minus, always a minus. Alright, so let's do the plug-in. So here is the plug-in. We have a 3 to the third power plus 5 over 2, and then 3 squared. So this is f of B, and then minus f of A. So -1 to the third plus 5 over 2 times -1 squared. Alright, and then I want to work this all the way out. So we have 27. Let's write this as well. So this is f of B, and then minus f of A. So that's the FTC. 27 plus 9 times 5, so that is 45 over 2, and then minus, this is always a minus from the FTC, and then that is a -1 plus 5 over 2. Alright, and then this is equals to, I want you to work this all the way out because I want to explain one more thing. So we have 99 divided by 2, and then this is a minus 3 over 2, right? So the answer is equals to 96 over 2. So we have 96 over 2. The area is equals to 48. Okay, so what is 48 represent? The 48 is the area under the curve of this function where x goes from -1 to 3. So this 48 is the area. So one thing that I would like to explain is what happens if you reverse the upper and lower limit. So if you reverse Let's put this back to the pen color. So what happens if you reverse the upper and lower limit? That is what happens if you have integral from 3 to -1. If you go like this, so you have 3x squared plus 5x and then dx, and then notice that nothing will change until you get to this step. So when you reach to this step, and then do you see that if you switch 3 and -1, the f of b and f of a, that the position will be swapped, right? So if you swap that position, and then these two will swap. So what that means is, if you do that, you will end up having 3 over 2 minus 99 over 2. The result is equals to -48. So what I'm trying to tell you is, so let's say the correct answer is equals to 48. You are doing homework online. The true answer is equals to 48, but you accidentally get a -48. Then you might be thinking, all right, so maybe I switch the upper and lower limit accidentally. So if that happens, you have to think about that. So the conclusion that we reach is, so here is the conclusion. Let's do it in a different color. So the conclusion is the integral a to b f of x dx is the same thing as, if you put a -1 in front of that, you can change this from b to a, f of x dx. So that is the conclusion that we reach. So if you swap them, then the positive area becomes a negative area, and the negative area becomes a positive area. All right, so let's move on to the next integral, the red integral. So we have integral from 0 to 4 square root of x dx. So the square root is 1/2 power. So x to the 1/2 dx, and that is equals to x 1/2 plus 1, 1 divided by that, such that x goes from 0 to 4. So you have x to the 3 over 2, and then 1 over that is a 2 over 3. Let's do a quick check. When you take the derivative of this, you can easily get back to the integrand. All right, so x goes from 0 to 4, and then you do the plug-in. So you have a 2 over 3. So the 1/2 is a square root. So you have a square root to the 4th raised to the 3rd power, and then minus 2 over 3. And then this one, you plug in a 0 to the 3rd power, so you have so this one gives you a 16 over 3. So that one is a 2/3 times 8, so that is equals to 16 over 3. This is the area. So what happens if you reverse them from 4 to a 0? Square root of x dx. Then you will end up having a 0, which is from here, and then you minus a 16 over 3. Then you will get a -16 over 3. Again, if you reverse the upper and lower limit, the answers becomes negative. If the true answer is negative, that becomes a positive. Alrighty, so how about the next one? The next one we have right here. So we have a 5 times a to the x. So the next two problems, they are exponential functions. So this is an exponential function. This is a natural exponential function. Let's do that. So we have integral from -2 to 1, 5 times a to the x dx. So this one, since the variable is x and phi is a constant, some people will write like this. They will just take the phi out, -2 to 1, a to the x dx. All right, so you can take the phi out because phi is a constant. And then what is the derivative of that? The derivative of, not the derivative, sorry. The integral or the antiderivative of this exponential function is, so the phi, no change. So you have, if you have a constant base raised to a variable, the derivative is equals to this. Watch. So this is a to the x divided by ln a. The base has to be greater than 0. So 1, 2, 3, 4, 5, 6, 7, 8. So you have the same thing divided by ln the base. If that is a 10 to the x, then this will be 10 raised to the x power divided by ln 10. If that is a 20 raised to the x power, then this is a 20 raised to the x power divided by ln 20. All right, and then such that x goes from -2 to 1, and then we apply the fundamental theorem of calculus. So we have a phi times a to the first power divided by ln a, and then minus phi times a to the negative 2 power divided by ln a. And then this one, what is that equal to? So this one, we have 5 times a, so that is 40 divided by ln a. And then the 1 over the a to the negative 2, so a to the negative 2, that is 1 over a square, right? So this one we have a 5, a square is 64, and then ln a. This one I would not do any approximation. I will just leave it as it is. So that is the area under the curve of the integrand where x goes from negative 2 to 1. So what's the next one? The next one is e to the x. All right, so the next one is e to the x. What color did I use? I used purple. Okay, so this is the integral e to the x, where x goes from, I believe x goes from negative 3 to 4, right? So negative 3 to 4, and then dx, the antiderivative of e to the x. This is a very special case. The derivative of e to the x is e to the x. The antiderivative of e to the x is what? The antiderivative of e to the x is still e to the x. So this is still e to the x, such that x goes from negative 3 to 4. So you have FTC. So e to the 4th power, always a minus e to the negative 3 power. I think this is it. So that is equals to e to the 4 minus 1 over e to the 3rd power if your instructor does not like negative exponent. And then the last one is ln x from 1 to 10. All right, so ln x from 1 to 10. So we have integral from 1 to 10. We have ln x dx. So this one, listen to me. So the integral of ln x, usually the integral of ln x, we do not say this is a formula. You are not going to study the integral of ln x until you study integration by parts. If you do not know integration by parts, again, if you do not know integration by parts, don't worry about it. I will just tell you what the result equals to. But before the textbook introduce integrations by part, I really don't expect them to give you such problem. Maybe they will give you this problem and then ask you to use a calculator. That is another story. But when you integrate by hand, I don't expect the textbook give you this. But it is good to know. Okay, so what is the integral of ln? The integral of ln is pretty long. So that is x times ln x and then minus x. That is the integral of ln. So this is from 1 to 10. And then you just plug in. So you have a 10, ln 10 minus 10. So this is one piece. It's always a minus. And then you have 1, ln 1 minus 1. What is ln 1? ln 1 is equals to 0. So ln 1 is always equals to 0. So the whole piece is equals to 0. So therefore, you have 10 times ln 10. And then this is a 10 minus the negative 1. So which is a negative 10 plus 1. So you have a minus 9. I know that is the last integral I gave you, but I would like to do one more. So that integral is here. The integral is, how about the integral of 1 over x, and then let's say this goes from 1 to 2 dx. Should we apply power rule? So this one is not a power rule. The integral or the antiderivative of 1 over x is ln x. You should pay attention to this. If you apply a power rule, you will get nothing. The power rule, if you apply power rule, x raised to the negative 1. So when the negative 1 plus 1, you will get a 0 exponent. Plus, you will get a 0, 1 over 0 in the coefficient. So this one, the integral of 1 over x is always ln. And then this goes to 1 to 2. So you have ln 2 minus ln 1. ln 1 is equals to 0. So the answer is equals to ln 2. So pay attention to this. All right, so that is the end of the introduction to fundamental theorem of calculus. If you like the way I explain math, give me a thumbs up, a subscribe, and I will see you all in the next video. Signing out.